Hey, Profit Stats, this is Mr. Monahan with the Lesson 2-1A video. The goal for the front of the note packet is I will be able to understand theoretical probability and find the probability of an event. So that's what we're looking to do. We are going to start the notes, make sure you have your note packet open to the correct page and that you are ready to write everything down and follow along. So if you're looking at this at home, don't worry about the part that says your number at the top. We're going to jump right into the notes. Our definition of random, and this is something we'll talk about in a second, outcomes are equally likely to happen. That's our definition of random, when outcomes are equally likely to happen. So human choices are not random. We're talking about things like you see a little bit below, which we'll talk about in a second. Things that have equal probabilities, like flipping a coin, you're either going to get heads or tails, and they should be equally likely to happen. So human decisions are not random. Randomness is most often, examples of randomness most pop up in things such as flipping a coin. That would be a 50-50 chance, heads or tails. Rolling dice, there's 6 sides of a dice, and they each are equally likely to pop up. Card games, since there's 52 cards, there's the same amount of each type of card. Those types of things are random. And then spinning a wheel, so like if you played Twister before, spinning a wheel in what sector of the spinner it pops up on. We're going to use randomness with our theoretical probability here. The theoretical probability is the probability that is supposed to happen when doing an experiment. The probability that's supposed to happen when doing an experiment. So we'll talk about right here how we calculate it, but it's what we think would happen without actually doing anything. The probability that getting a heads on a coin flip would be the number of ways you can get heads, the number of favorable outcomes, divided by the number of possible outcomes. So like I said, if it was the number of ways to get heads, there would be one way to get head on a coin, and there's 2 possible things that could happen when you flip a coin, so it would be 1 out of 2 chance. Remember, sample space, same definition from chapter 1, all the possible outcomes in an experiment or in an event. An event is a specific outcome that you want to have happen. So the event that I would be looking for is flipping a coin and getting heads. The sample space is heads or tails. So there's one way to get heads out of 2. So 50-50, 1/2 probability. Hey, feel free to pause the video if you have anything there that you still need to write down. For example, what is the probability of spinning the green space on this spinner? So they want the probability that we land on the green space. So just pay attention to this format here. P stands for probability, and then in parentheses we write the thing that we want to have happen. So what we need to do is we up top we want to put the number of green spaces. On the bottom we want to put the number of spaces. Up top is how many ways we can successfully get a green. On the bottom is how many possibilities there are. So if you look at the spinner, there's exactly 1 green space, and there are 4 spaces. So this brings up the question of what is an acceptable answer for probability. And this would be a potential answer that you could use. You could get a decimal for it, 0.25, or you could use a percentage. Any of these 3 formats is okay. If you use a fraction, it has to be a simplified fraction in order to be correct. So a simplified fraction, a decimal, or a percentage, any of those would be an answer that would be okay. And that'll be covered here when we talk about the basic rules of probability. Make sure that you have these written down. Pause if I move on too quickly. Probability answers, they must land between 0 and 1, so you can't have a probability that's 110%. That is not possible. Speaking of not possible, a probability of 0 means that it cannot happen. So pigs flying, 0% chance. Probability of 1 means it's absolutely going to happen. The sun will rise tomorrow. 100% chance. The closer to 1, the better chance of happening. So higher probabilities mean it's more likely to occur. Lower probabilities mean it's less likely to occur. Rule number 2, all the probabilities of a sample space must add up to 1. So if there's a 40% chance that it rains, that means there's a 60% chance of no rain, because it's either going to rain or it's not. There's no middle ground. Those two numbers have to add up to 100% or 1. Okay? Rule number 3, the probability of an event not occurring, and we'll talk about, well, actually the one I just did was a good example that we'll see again. The probability of an event not occurring, so pay attention to this symbol here. P stands for probability. Remember that the apostrophe means not. We talked about that when we did Venn diagrams. So this is saying the probability that A does not happen is 100% minus, 1 minus the probability that it does happen. It's sometimes called the complement. So then these symbols are equivalent ways to talk about the complement. Either A with a C for complement or a squiggle and then A. They all mean the same thing. But the formula for it is right here. If you want something not to not happen, you take 100% minus the probability that it does happen. Feel free to pause or rewind for anything that scrolled too fast. So we'll look at, on a dice, the probability of rolling a 4. It would be the number of ways to roll a 4 on a standard 6-sided dice. There's 1 4, and there's 6 total options on a dice. Okay? Unless they said it was a 10-sided or 12-sided dice or whatever. 1/6 would be an okay answer. So would 1.67 or 16.7%. We always go to that third digit, and we make sure that third digit is rounded appropriately. So that when we have the percentage, we have the 1/10 of a percent. We round to the nearest 1/10 of a percent. Cards, choosing a red card. Remember that there are 52 cards in the deck. Half of those are red. So half of the 52 cards are red. That would be 26 out of 52. We can't leave 26 out of 52 as our answer because it's not simplified. So I would not accept that answer. So you could simplify that fraction all the way, and it's actually 1/2. Or you could write 0.5, or you could write 50% or 50.0%. Coins, I've said this one a couple times already. The probability of getting heads, there's 1 heads on a 2-sided coin. So this would be the same answer as above. Any of those 3 answers would be fine. You don't need to list all 3. Having a specific teacher, for this one, we would need to have how many science teachers there were, how many teachers there were. So it would be 1 out of the number of teachers. So Olson's a science teacher. So I'm just going to leave it like this right now, because off the top of my head, I don't know how many science teachers there are. So sorry about that one. That one's not really a final answer, but there's one way to have Olson. We would divide it by however many science teachers there are. This one right here, for the spinner, it says the probability of orange. I don't see orange anywhere on this spinner. So in this situation, it looks like I have blue, red, yellow, and green. If they ask for the probability of orange, there's 0 ways to get an orange, land on the orange section out of 4, which is 0%. So those are some basic examples. We'll continue to move on and show you some more things as we go. Let's get into a little bit more complicated one. What is the probability of getting 3 heads in a row when flipping a coin? So now there's more than one event happening here, so this is a little bit more complicated. So the plan of attack, we could say for this one, is figure out the sample space. How many different ways can I flip 3 coins? One way to do this would be with a tree diagram. On the first flip, I either get heads or tails. On the second flip, I either get heads or tails. On the third flip, I either get heads or tails. And that's how many flips I want. I want 3 flips. So if I count how many are in this column, there's a total of 8 different outcomes that are possible when you flip 3 coins. So that question is answered. So find the number of desired outcomes. How many of these have heads, heads, heads as our options? Well, just one, right? Heads, heads, heads. Okay. Every other possibility has at least one tail in it. So there's one way to do this. So then the probability then is answer the question. Well, the probability of getting 3 heads, or we could even do it this way too. The probability of getting heads, 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 either way would be fine, is there's one way to do it out of 8 total possibilities. So that's equal to 0.125. Go to that third decimal place, or 12.5%. That would be another acceptable answer. All right, well, since we already have the tree diagram, we can answer this question too. We want the probability of flipping 2 tails and 1 heads. Okay, all right, so 2 tails and 1 heads. So the probability of getting 2 tails and 1 heads, we have to think about the number of ways that's possible out of 8. Okay, well, here is one solution that has 2 tails and 1 heads. Tails, tails, heads. That's one way to do it. Here's another one. Tails, heads, tails. That's 2 tails and 1 heads. Here's another one. Heads, tails, tails. And that should be it. Every other option has either 2 heads or 1 head or 1 tail. So those would be my 3 different ways to get 2 tails and 1 head specifically. So there's 3 ways to do that. That's an okay answer. So is 0.375. So is 37.5%. If it asks at least, what's the probability of getting at least 1 tails? Okay, well, probability of at least 1 tails. Okay, well, there's only one way that we don't have a tails. H, 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 that has 0 tails in it. Okay, everything else has at least 1 tails in it. So if I know that there's 8 outcomes and there's only one way to not get at least 1 tails, that means there are 7 ways that you can have tails. Okay, so that's 7/8, which is 0.875, which is 87.5%. So that one was using the complement a little bit. Notice that the one I have in green is the complement of what I have in blue. These are complements of each other. They add up to 1. You're either going to get at least 1 tail or you're going to get 0 tails. There's no in between on that. And then I think that's about what we have. But just as a recap of what we said, you have to make sure if you use a fraction that you use a reduced fraction. So 25 out of 75 would be a wrong answer. Even if you do the probability correctly, I will mark that wrong. So you want to make sure it's reduced all the way. So they both have a factor of 25 in it. If it's a percent, then we want it rounded to the 10th of a percent. So if we have like 0.8689, okay, that would be a decimal, right? So 0.8689 would round to 86 since this number is bigger than 5, it's going to round up that digit. We would call that 86.9%. If you get small numbers with lots of zeros before your first digit, we call those significant figures. So if you were to punch in 1 over 66,633, you would see a bunch of zeros before you get any significant digits. We would round to those first 3 significant digits. So all that means is you would have 0. If you punch this in, if you do that, let me check my calculator here. It looks like you get 0.000150076, yada yada yada. Okay. Well, when we do that, we would either put it in terms of scientific notation, or these would be our first 3 significant figures. So we would round that 7 up to a 1. So we would say that it's 0.000151. That would be the rounded answer. That's what sig figs means, significant figures. If you get small numbers like that, a lot of times you'll leave it as a fraction that's just reduced. So I would say that this would probably be the best answer for this one. Okay, that's it for today. So the goal was to be able to figure out and understand theoretical probability and to find the probability of an event. So there might be some of those trickier ones in there today, but for now, that's all we have to worry about. Go ahead and try it. The first 3 pages of the packet, it's not actually yellow, it's actually salmon color. But good luck. Let us know what questions you have.